So as I highlighted, basically in order to mitigate the key challenge, we try to get help from the seismic data. So first we find out the seismic resolution through the wedge modeling. However, the wedge modeling suggested that the resolution of this seismic at this point is 40 feet. But again, the challenge was basically the sand thickness within the oil-water contact or in the intercept zone was from 5 to 22 feet. And that was very good porous sand. So, then we took help, try to basically get help in terms of qualitative attributes. So we get basically sweetness, instantaneous sweetness attribute. So it helped basically to define the two zones. This was the first the zone where the previous well was located, and now this is the area which we interpreted as a tight, and then it highlighted another zone in the north part of the structure which was still untested. So in order to test this concept, we drilled one well over here, basically at this point. So the results were very encouraging. It basically gave us the 10 feet of the sand in this well, and that has very more than 20% porosity, and oil was basically it was oil bearing. So after that, we drilled multiple wells in this area to develop basically that northern part, this northern part. So this is the second field, which also have the same sort of challenge, but its challenge was slightly different because it was a relatively thick reservoir, but within that thick reservoir, there were multiple channels present in that. So again, the resolution challenge was there. So same scenario was this field, even this zone was not initial of our interest, because this also field was producing some other sand, and it was in the stage of decline and very limited production from it. So basically there were 3 wells initially, that's why these zones were untested. There were 3 wells. This is the map. First I will just go through the structure of this area. So this is the field basically which is dependent on this blue fault, which is dipping in this direction. And so there were 3 wells, Y1, 2, and 3, which were initially drilled at the crest of the structure. So they all have tight reservoir quality, and one analog representation we have shown here on the left side. This is the interpreted log, and basically it could not produce. The sand was tight. So after when we work on that, then we drilled and tested this yellow basically concept of this yellow facies, which I'm going to further discuss in the coming slide. So the well which was drilled in this yellow patch, so now this is a picture that it encountered a good quality sand in this well. And after that, basically we explored the multiple opportunities by targeting these zones in the area, and it added significant potential in the portfolio. So here, yes, as it's a fluid deltaic session, so there is a challenge is basically to define the geometries or the layout of the reservoir. Because usually as our focus is to target the reservoir in the good quality fairway. So in order to basically mitigate that risk, we run multiple attributes, but at the end, they gave some picture, they gave some deposition trend in the area. So, but ultimately the challenge was that where we target the sand. So in that scenario, this is basically this color map is the waveform classification map. So this attributes works that it's cluster the same sign of waveforms, like similar cluster of waveforms of the similar lithology, and it develop different color scheme or different classes. So we get the picture that it is dividing this area in the 5 classes, which from in the way if you look at the map, there is a bottom, there is a color legend. So when we tied in with the well data in the area, so that guided us that basically the well which are located or close to this yellow patch, they have good quality sand in this package. So here I have just highlighted the wells which are located in the yellow patch. They have the good quality sand, and there are the wells which are away from this yellow patch. They have the tight reservoir quality. Okay, sure, just standing. So basically, this further help us to identify multiple opportunities even in this area. If you look that the one patch is located over here, then other thick patch located over that. And similarly, below this fault compartment, there is also these distribution or sand deposition was placed over there, which we targeted and get successful results. So this third field is just we have added was to emphasize the basically importance of thin zones, very thin zones in the, especially in the matured asset, because sometimes these thin zones can have significant potential in the area or in the, basically in the area. So the same scenario was that this was the field where we have only one control at the down dip part of the structure, and it has very, only this 8 to 10 feet of sand in the located over there. So we have available the rest of the structure, there was no penetration, but the challenge was that how we can mitigate the lateral continuity or we can reduce that risk. So in order to mitigate, when we carried a regional correlation in the Badin concession and correlated that overall this package, this sand package is basically deposited throughout the area. And it gave us concept, so we tested a well over up dip part of the structure, somewhere here. So it also encountered similar, basically the sand at the same point, and with the oil bearing, there was oil, it was oil bearing. So it added, even this thin zones added basically 4 to 5 million oil in place, proven oil in place in the portfolio.